In this lesson, we are going to introduce some ideas about lines and angles. There will be some things that are familiar, some vocabulary words that you've heard in the past, but I'm going to go over them. And then we're going to talk about how we can apply that to what are called theorems about lines and angles. So starting out, a couple of things that we should already know about angles is, first of all, how can you name an angle? So when you name an angle, that means that you call it something. And so this angle right here that we see, that actually can be called a couple of different things, and then it means we're talking about the same thing. So in this angle, the most important thing that we see first is called the vertex. And so B is the vertex. Okay, and so every angle has a vertex. And then the sides of the angles, they're called rays. And so an angle is formed by two rays that come from the same vertex. And so ray BC and ray BA form this angle. And so we can call this, and most people are really okay with calling it angle 1. So that's one thing we could call it because it says 1 in the middle. We can also call it angle B because that's the name of the vertex. Now we can do that as long as there's no other angle B that, could be talking about a different thing. So like if I had another angle right here, so angle 2, if I had that one, and that one also has a vertex B, so then I couldn't call it angle B because I don't know which one I would be talking about. So if there's any risk of confusion, then you cannot name it by just the vertex. Now to always be safe, you can call an angle by the 3 points that form the angle. So you could say angle CBA or angle ABC. And notice that in both of those, the vertex is in the middle. So there's 4 ways that you can name this angle and be talking about the same thing. And so again, as long as there's no risk that you might confuse anything. Okay, now the next thing that we're going to talk about, we've got this group of different lines, line segments, lines, and it's got different numbered angles. So angle 1, angle 2, and angle 3, and so on. And then there's these different vocabulary that's on the side. So I'm not going to name everything that would be an example, but I'll give you some examples of each type of angle. So the first one is adjacent angles. Now the word adjacent means next to. Okay, so two angles that are next to each other. So examples would be like angle 1 and angle 2. Those are adjacent angles. Angle 6 and angle 7. Those would be adjacent angles. Angle 7 and angle 8. Those are adjacent. Angle 4 and angle 5 would not be adjacent, okay, because they're not next to each other. So these adjacent angles have to be sharing a side. So 1 and 2, they share that side, and 7 and 8 share a side. 4 and 5, they don't share a side. They're two distinct angles that don't share anything in common there. They share a side, but they don't share a vertex, I guess. They would have to share a vertex and a side to be adjacent. Okay, a linear pair. So the word pair, of course, means that there's 2 of them. Okay, so a linear pair has to have 2, not 3, but 2. And together they have to form a line, so a straight line. So in other words, they have to make a 180-degree angle. So examples would be angle 1 and angle 2 would be a linear pair because when you add them together, it makes a straight line. Another example, if you can look at your picture, we could have angle 5 and angle 9. Those would be examples of a linear pair. Can you find another example of a linear pair? There's actually a number of them. One example that would not be a linear pair would be something like 6, 7, and 8. So even though that does form a line, it's not a linear pair because there's 3 of them. Okay, the next one is vertical angles. Vertical angles are a very important thing to know, and this is something that we did talk about last year. And vertical angles, if you remember, they're formed when you have 2 lines that intersect, and the angle that is formed by that intersection, the non-adjacent ones, those are vertical angles. So examples in this picture of vertical angles, those would be like angle 2 and angle 4. So go ahead and see if you can list another set of vertical angles. You may not list exactly the same ones I'm going to list, but angle 9 and angle 6 would be an example of vertical angles. Some of you might think maybe 7 and 5, but they're not, because if you look at 7 and how that's formed, you would need another line to make 5, and so that does not make a vertical angle. There are some other examples in there of vertical angles, but 6 and 9 are the only ones that are in this set right here. 6 and 9. There's no other vertical angles in that picture on that side. In the 1, 2, 3, and 4 angles, you can find some other sets. Okay, supplementary angles. You need to know what the word supplementary means. Supplementary means that they add to be 180. Complementary means that they add to be 90 degrees. Okay, so you need to remember that terminology. So supplementary angles, it's any angles that add up to be 180 degrees. So examples would be like angle 2 and angle 3, or angle 5 and angle 6. It also could be more than 2 angles. It could be like 6, 7, and 8. So I'm going to write that angle 6, 7, and 8. Those could be supplementary angles because they add up to be 180. So it could be more than 2 angles that could be supplementary. Complementary angles are angles that add to be 90. So in this one, you have to know that angle 7 is 90 degrees. And so what else would be 90 degrees? Well, angle 9 and angle 8 would be 90 degrees. There's nothing else in that picture that you would know that it was 90 degrees. So that's actually the only answer for that one. And then right angles, of course, you know that, and that's angle 7. That would be the only one that I would say is a right angle. You could say angle 9 plus angle 8, but that's just kind of more in the complementary angles section. Okay, now the next one we're going to talk about is when you have parallel lines. And again, this is something that we did talk about last year. But when you have two parallel lines and they're cut by a transversal, it forms all of these angles. And so when it makes all of these angles, it creates these different relationships that occur. And so I want you to pause the video and I want you to go through and take each of these lists, and I want you to see if you can remember what they mean. And so see if you can list a set of angles that would be that type, and then turn the video on again and see if you got it right. And then I'm also asking you if they're complementary or supplementary. So would they add to be 90 or would they add to be 180? So go ahead and pause the video and see what you can do. Okay, hopefully you were able to find some things that you knew. So just from talking up above, linear pairs, can you identify 4 pairs of linear pairs? So I'll just go through and name a few. So one pair of linear pairs would be 1 and 2. Another one would be 2 and 4. Another one would be 4 and 3. Another one would be 3 and 1. And we haven't even gone to the other set of numbers yet. So you can easily do 4 sets of linear pairs. Linear pairs, by definition, they have to be supplementary because they're going to add to be 180. Okay, vertical angles. There's a lot that you could have named. You could have said 2 and 3 are vertical angles. You could have said 1 and 4 are vertical angles. You could have said 5 and 8 are vertical angles. You could have said 6 and 7 are vertical angles. So any of those would be fine. Now, as far as congruent, oh, sorry, I didn't see it was congruent or supplementary. They're actually congruent. They're not necessarily supplementary. If both of the angles were 90 degrees, then that would be supplementary, but we don't know that they are. Okay, now the next one, this one's going to have to, you might have had to dig back in your memory and see if you remembered talking about this. But corresponding angles would be angles like 2 and 6, or angles like 3 and 7. So look at how those angles relate to each other. Like the blue ones that I marked 2 and 6, they're both above their parallel line and to the right of the transversal, so they correspond in their location to each other. So I'm just going to write examples like angle 2 and angle 6 as an example, and they're congruent to each other. So we did talk about that last year, but that needs to come back, and we're going to be using that a lot. That's probably one of the most important theorems that has to do with parallel lines. Okay, the next one, alternate interior angles. So the word alternate, think of what that means, and interior. So an example would be 4 and 5, angle 4 and angle 5. Those would be alternate interior. There's one other set of alternate interior angles, and alternate interior angles are congruent. Okay, alternate exterior. Alternate exterior would be like 2 and 7. Okay, and they're also congruent. Same side interior, those are going to be angles that are on the same side of your transversal but are on the interior. So that'd be like angle 4 and angle 6. Now the thing with same side interior, and they're also known as consecutive interior, but the thing with those is they're not congruent to each other. You can kind of look at the picture and see that they wouldn't be congruent. They are in fact supplementary to each other. As long as your lines are parallel, then those are going to be supplementary. And then same side exterior, those would be like angle 2 and angle 8, and those would also be supplementary. So those are some things that I'm going to just put a big star by this whole thing, and you need to know what all of those phrases mean. And then as we move on, we're going to be using those ideas. There's actually theorems about all of these, and a theorem in geometry is a statement that you can prove, and it is kind of like a basic building block of the geometric ideas that we have. Now there's also what are called postulates. Postulates are actually more of a basis than theorems are. You cannot prove postulates. They're something that's accepted to be true because there's nothing else that it could be. And so an example of a postulate is the corresponding angles postulate. That's actually a postulate. And then based on that, you can prove all of these in this bottom row. And so that's just kind of an interesting thing. The linear pairs, that's like a definition. And then because of that, you can prove vertical angles. So proving something is just using something that we already know to be true to prove the next thing. And so we're going to be doing some of that. Okay, let's go to the next side. And so some examples where we work with complementary and supplementary angles. We're going to find some missing measures. And so we use our algebra skills to do this. So for example 1, it says if the measure of B is 37, find the measure of its complement. So remember, complement is you add to be 90 degrees. So you can just do something as simple as say 90 minus 37, and you get 43. And so the complement of angle B is 43 degrees. And so there's different ways that we can write that, but sometimes what we do is we write like this, a line over and then the measure of angle B, so the complement of the measure of angle B. But it's okay if you just want to write the complement of angle B equals 43 degrees. Okay, so just write it so that we know what you're talking about. Number 2, A and B are supplementary, so think about what does that word mean. So find both the measure of angle A and angle B, and you know that they have to add up to be 180 if this is true. So since these two statements are true, that's angle A and angle B, what do you know about them? You know that if you add them together, it's going to be 180 degrees. So you set up an equation, and then you just use algebra to solve that. So you're going to put your like terms together, and then solve for x. And so x is going to be equal to 37 degrees. Now that's not the answer to the question because the question wasn't solve for x. So find the measure of angle B. So angle A and angle B. Angle A is 2 times x, so that's going to be 74 plus 5, so that's 79 degrees, which would make this one 101. And then you can check 3 times 37 minus 10, make sure that that's 101, but that's how that's going to work. Okay, for the next 3 examples, it says, given that the lines that appear parallel are parallel, solve for x and y. So you're going to use what you know about corresponding angles or alternate exterior angles. So what we did on the previous page, down here, you're going to use all of that to solve these problems. And so I'll just show you one example, and then you can pause and do the other ones. But if you look at number 3, this is talking about this angle right here, and this one's talking about that angle right there. So first of all, what types of angles are they? And so they're on the outside, they're alternating sides, they're alternate exteriors. So we know from our previous page that they're congruent to each other, so you write an equation about that. And so what I expect to see on your paper when you turn it in is I expect to see that you wrote an equation. I don't expect to see just an answer. That doesn't show me what you did. And so make sure that you show me how you're doing your work and what you're doing to make this, to show what you're learning and what you're doing. Okay, so we're going to show what we're doing to both sides there. So we're going to have 54 is equal to x. And so that's what x is equal to. Okay. Now you go ahead and pause and do number 4 and number 5. So you're going to decide like what am I solving for and what's the relationship. On number 5, notice you have both x and y. So go ahead and pause and see what you can do with that and then turn this back on. Okay, number 4, you look at 2x and 3x, and those two angles, they are a linear pair. So they add to be 180 if you look at that. So 2x plus 3x is equal to 180, and so 5x is equal to 180, and so that's pretty easy to solve. So 5 goes into 180, it's going to be 36 times, so x is equal to 36. Now it's not 36 degrees because we already have a degree symbol right there. There's a degree symbol right there. So you just are going to say 36. So 3 times 36, and then that's in degrees. Okay, for number 5, you look at this one, and we have to just focus on one variable. So these two right here have x's, and they're alternate interior angles. So what I'm going to do is I'm going to set up an equation for that. So 2x plus 13 equals 3x minus 24 because I know that they're equal to each other because they're alternate interior angles. I'm going to subtract 2x from both sides, and I'm going to add 24. So I'm going to have 37 is equal to x. Now that's not it. I know what x is, but I have to find y as well. So how do I do that? Well, since I know x is 37, what if I do 2 times 37 is 74, plus 13, plus 13, so 74 plus 13 is 87, and so this is 87 degrees right here. Well, what do I know about that angle then? I know that these two angles add together make 180, so 180 minus 87 is going to be 93 if I did that right. And so 3y plus 24 is equal to 93. Now solve it for y. So subtract 24 from both sides, divide by 3, and you get your y. So I'm going to let you guys just go ahead and check that. I've got it on the answer key for that, but that's how you would do something like that. Okay, now the next thing we're going to do is we're going to do some proofs. And last year we did a little bit with some proofs. We're going to kind of start out with just some easy things, but if you remember from proofs when we did that, the first thing that we always did was we started with our givens. And so what were we given? And so we're given in this one, it says lines L and M intersect to form vertical angles 1 and 3. So we're given that L and M intersect, and we also are given that angle 1 and angle 3 are vertical angles. And that's because it's given to us. That's the reason that we have that, okay? Now what are we supposed to prove? We're supposed to prove the vertical angle theorem. We're supposed to prove then that the vertical angles 1 and 3 are congruent to each other. So how do I do that? So how do I prove that those two are congruent? You can't say they're congruent because they're vertical angles, because that's what we're trying to prove. So look at the picture. What else do we know? I know that, for example, 1 and 2 are supplementary because it's a linear pair. So I could say that the measure of angle 1 plus the measure of angle 2 equals 180. And that's because it's a linear pair. And I know that linear pairs are supplementary. Okay, what else do I know? I also know that angle 2 and angle 3, same thing there. So I can just put that in the same reason. Angle 2 plus the measure of angle 3 equals 180. And I can just group that in there because it's the same reason, linear pair. Okay? Now, when you're doing proofs, you have to kind of get creative and kind of think around in circles and think, well, how can I get to where I'm supposed to be? And so I'm trying to prove that 1 and 3 are the same. And so if you look at what you have in statement number 2 right there, I have that 1 plus 2 is 180. 2 plus 3 is 180. So if you think about it, if I say angle 1 plus angle 2 is the same thing as angle 2 plus angle 3, how could I prove that angle 1 was congruent to angle 3? Think of algebra, okay? I can say that measure of angle 1 plus measure of angle 2 equals measure of angle 2 plus measure of angle 3. And the reason I'm doing that is because I substituted, instead of saying 180, I substituted on the other side of the equation something that's equal to 180. So for number 3, that reason is going to be substitution. When you substitute something of equal value, that's all substitution is. So I just substituted something of equal value. Okay, now thinking of your algebra, I'm supposed to get to where it says the measure of angle 1 is equal to the measure of angle 3. So algebraically, what if I just subtracted the same thing from both sides? So I'm kind of running out of space here, but for my step number 4, I'll write it over here. I'm going to say the measure of angle 1 is equal to the measure of angle 3. Why? Because the subtraction property of equality, if you remember that from last year, we did that earlier on. And if you subtract the same thing from both sides in an algebraic equation, then it is still equal. And so I've proven what I needed to prove. And so that's my proof. So none of the proofs that we're going to be doing right here are going to be very long. But you're going to have to think about how can I get from A to F, and how can I get, to that point. But you have to be very careful about how you do that. So let's look at number 7, and let's look at what we are given and then where we have to get. Okay, so we're given that angle 4 is congruent to angle 6. So I'm going to mark that. Okay, so, all right, those are congruent. And then maybe before you do the rest of it, just think about, well, what else do I know about this picture just because of the way it's drawn? What else do you know? And I always find that this helps a lot in proofs, is just to kind of think out, like, what are some other things that I know? Like, for example, I know that angle 1 and angle 4 are congruent. Why? Because they're vertical angles. I also know that 2 and 5 are vertical angles, so they're congruent. I know that 3 and 6 are vertical angles, so they're congruent. Okay? I know things like 3 and 4 and 5 are supplementary, so that might be helpful. So just thinking of these things that I might know, or that I know that might be helpful, that's really going to help me a lot get started on my proof. So the first thing I always do on a proof is I list my givens. So angle 4 is congruent to angle 6, and that is given. Now, what I'm supposed to prove is I'm supposed to prove that angle 1 is congruent to angle 3. So I'm going to put that just kind of in yellow. So I need to prove those. So I can kind of think like, well, I know that 6 and 3 are congruent because of vertical angles. And I know that 4 and 1 are congruent. Let's write that down. Whoops, not step 1. Step 2. Angle 1 is congruent to angle 4 because vertical angles. And since it's exactly the same reason that 1 and 4 are congruent, that 3 and 6 are congruent, I'm just going to lump that in there as well. So angle 3 is congruent to angle 6. Okay, so I've shown that. Now, up above, notice that we said 4 and 6 are the same thing. Those are the same thing. So what I could do is I could say angle 1 is congruent to, instead of saying angle 4, I could say the same thing as angle 4 is angle 6, which is the same thing as angle 3. And so that's just a series of substitution. Okay, so angle 1 is congruent to angle 4, which is congruent to angle 6, which is congruent to angle 3, and so that makes it 1 is congruent to 3. That's also something called a transitive property. I don't like to use that one a lot. It's very much like substitution, but it's kind of like if A equals B and B equals C, then A equals C. That's exactly what it says, actually. And so that's a transitive property, but I'm okay if you just write substitution because it's really just a series of substitution. And so that makes it kind of easier to remember, but that is called a transitive property. And so we've proven then that angle 1 is congruent to angle 3, and so there you go. Okay, what I'd like you to do now is on number 8, I would like you to just see what you can do. You may not be able to do the whole proof, but I know you can do the first step. And I want you to mark the things that you know and just kind of think and see if you can get somewhere. There's a couple of different ways to approach this problem, but I want you to just see what you can do. And then if you feel comfortable, go on to do 9, 10, and 11 and just see if you can get somewhere with that. It's not a matter of I expect you to be able to do it perfectly right now, but you can try and see what you can do. And then come back in here and just see like what part of it you did right and what did you miss or what did you not understand. Sometimes we have to try things before we really understand what we don't understand. So go ahead and pause it. I'm going to go ahead and switch videos now, and so then you can come back and you can see how you did on this.